This is the video for Section 8-3 on surveys, experiments, and observational studies. Key vocabulary in this lesson is experiment, observational study, control experiment, control group, treatment group, randomized comparative experiment. And the essential question is, what are the commonalities and differences between surveys, experiments, and observational studies? An experiment imposes a treatment on individuals to collect data on the response of the treatment. So for example, a researcher adds acetone to gasoline to measure its effect on fuel efficiency. So the key thing to have an experiment is that there is a treatment being imposed. An observational study observes individuals and measures variables without controlling the individuals or their environment in any way. So for example, a researcher wants to find out if poor nutrition affects eyesight, but it would be unethical to deliberately subject some individuals to poor nutrition. So an observational study, you're literally observing the individuals, but you do not have any control. For data from an experiment to be useful, the experiment must be carefully designed. In a controlled experiment, two groups are studied under conditions that are identical except for one variable. This one variable is what we call our treatment. The effects of the treatment are determined by comparing the control group to the treatment group. Often, to demonstrate a cause and effect hypothesis, an experiment must show two things. First, that the phenomenon occurs with the treatment, and second, that the phenomenon does not occur in the absence of the treatment. In a randomized controlled experiment, the individuals are assigned to the control group or the treatment group at random in order to minimize bias. An experiment that is not randomized comparative experiment may be subject to bias, and any conclusions drawn from that experiment may not be valid. So if you look at the little diagram here, you have the randomization control experiment, which whatever amount of subjects you have here, they are randomly placed either in the treatment group, which means they received the treatment, or they're placed into the control group, which is used for the comparison, and they do not receive the treatment. Examples. Example 1 says to explain whether each situation is an experiment or an observational study. A researcher wants to know if the soil additive makes a fern grow more quickly. He grows one specimen in treated soil and another in untreated soil. So in this example, if you look and read it carefully, you see that there is a treatment being imposed. He has treated soil and untreated soil, so this would make this an experiment. So as I just said, the researcher applies a treatment, so the situation would be an experiment. Part B says, to find out whether car accidents are more likely on a rainy day, a researcher records the weather conditions during 50 randomly selected accidents per year. So in this example, there's no treatment being imposed. The researcher is just simply going back and looking at the data, so this would be considered an observational study. Example 2 says the study described in the report is a randomized comparative experiment. Describe the treatment group, and the control group. So to test the redesign of the website, an online bookseller assembled 96 users of the site and randomly divided them into two groups. One group used the new website to make an online purchase, and one group used the old website to do the same transaction. Users of the new website were able to complete the purchase 22% faster. So in this example, the treatment is using the old and the new websites in order to make the purchases. The treatment group consists of the users of the website using the new website to make the purchases. And the control group consists of the users of the website using the old website to make purchases. Example 3. Explain whether the research topic is best addressed through an experiment or an observational study. Then explain how you would set up the experiment or the observational study. Do people who consume 1,000 milligrams of vitamin C each day as a dietary supplement have a lower cholesterol level than people who do not consume vitamin C supplements? So because you don't know the effects of the supplement, then an experiment would be a better um, way of looking at it. And what we would do to set up this experiment is we would first have to randomly choose one group of people to take the supplements. We would then randomly choose another group of people to not take the supplements. So you have one group taking the supplements and another group not taking the supplements. And we would monitor the cholesterol levels in both of these groups and then compare our results. Example 4 says to classify each method as a survey, an experiment, or an observational study, and explain which would be the most reliable. So for the first part, as we read them, we're going to be looking at, are we asking questions, which would be a survey? Are we imposing a treatment, which would be an experiment? Or are we just looking at something and observing it, which would be a observational study? So in method A, we're randomly choosing 50 people to exercise 3 hours a week and 50 people to participate in another activity, and then we're going to monitor their health. So because we're randomly choosing people and placing them into treatment groups, this would be an experiment. Method B, randomly choose 100 people, ask how many hours a week they exercise and how healthy they are. So because you're just asking questions, method B would be a survey. Method C says choose 50 people who exercise regularly and 50 who do not, and monitor their health. So on method C, you aren't placing them into groups. They're already in groups. You already have the people who do exercise and you have the people who don't. So since you're just observing here, this would be an observational study. And then remember, in order for results to be reliable, you want something where you definitely have a comparison group and the subjects were randomly placed into different groups. So because B has no comparison, you're just simply asking questions. B is your least reliable. Method C has a comparison group, but the members are self-selected, which could lead to bias. So C is somewhat better than B, but it's not the most reliable. And in method A, the members of each group were randomly selected. So because you randomly put them in there, you reduce the bias. And you have a treatment group and a control group. So you also have your random part is taken care of and your control part is taken care of. So method A would be the most reliable.